Hi everyone, I'm Professor Casey, and today we're going to talk about strings in this two-part video. The first part will focus on chars and strings and how they're different, as well as how to assign things into a string. The second part, a different video, will focus on string functions and some really specific functions we can get into in the string library about how to manipulate strings. The focus of this presentation will be on reading and printing in string functions, as well as how to process string functions. In this specific lecture, string functions are a lot focused on assignment, so how we can assign things into strings and how they're different from doing things with just one individual char. We'll also do a lot of different examples to kind of illustrate these topics. Let's talk first about some of the big ideas of this lecture. In 106, we did a lot of work with arrays and reading in data from things like files. However, we have to remember, in the big scheme of things, we won't always be using data that is numerical. Sometimes we'll have data that is things like words or characters. When we're talking about chars and we're talking about strings, we're talking about an array that's made up of characters or of chars. So a string, all that you have to remember about strings is that it is an array of characters. Reading in one character isn't always super helpful, so we need to learn how to read a bunch of them in all in a row without having to use a bunch of loops and if statements and things like that. And we'll learn about basic string functions. Some applications that involve strings, you might be thinking, why do I need to know this? Well, when you're reading and writing inside the serial monitor, especially on Arduino, we're going to be typing a lot of strings back and forth, and being able to type these messages using things like sprintf in Arduino is going to be really helpful. We'll also talk about printing and debugging messages as well as reading data in from CSV files. This is really important for data manipulation and data processing. We'll also touch a little bit on keyboard input from the user, from the standard input, and databases. Okay, so let's start with the basics. Let's start going all the way back just to characters. There are two main methods to process characters from the standard input. What do I mean by the standard input? I mean the command prompt window, the black screen that pops up, or the serial monitor if you're in Arduino. The two methods, one you've definitely seen before is scanf, right? Scanf is pretty versatile. We could scan in a char here and save it as C, but we can also use scanf to scan in ints and floats and all sorts of different things. The second way you can process a character is with a function called getChar. If you remember, you've actually seen this in the workaround for Zybooks in 106. We use this getChar function. And what this does is takes one character at a time, but converts it to an integer, which means we're using the ASCII table. So these are the two main ways we can process characters from an input. We can also process single characters using getC and fgetC. getC was actually taken out of the C standard library in 2011. It will still work, but it's just as easy to use getChar. fgetC is specifically for getting one individual character from a file. And if you use fgetC, you're going to have to use the file pointer like we talked about in 106. Remember that with any character input, except from a file, you will have to use fflush to clear that standard buffer. Let's talk about character processing for outputs. So same thing, there's two main methods here. We can use printf, and just like with scanf, printf can be used with any type of input here. So we can use %c for a character, but we could also use %d or %f or %lf for any type of other data type that we want. Putchar, on the other hand, only involves characters, and it also, just like getChar, converts the character to its integer form. So we're using the ASCII table here. Similarly, just like with fgetC, we also have fputC, which takes one single character and puts it into whatever file we've specified with our file pointer. So again, three main ways, two ways to do it with the standard output, so printf and putchar, and one way to do it with a file, and that's fputC. Okay, so let's look at some examples really quickly using those functions we just talked about. Okay, so here I have a really quick example on just how getChar works. I have to print my instructions to the screen, and then I declare my char, it's called C. I don't put anything in it because I want to actually get whatever they're entering from the standard input. I don't have to specify the standard input, it's built into this function. getChar will automatically pull from the standard input. I then have this loop which just allows me to enter as many characters as I want and keep printing them until I get to my end of file. Now, will I get to an end of file if I'm entering into the standard input window? No, I won't. So this basically will just go forever. So I'm going to be able to enter any character, and it should be able to spit that character back out to me. So let's try with K, right? It spits it back out. How about P, W? Now, can I enter numerical values? Yeah, they're still characters. How about punctuation? Of course, still a character. So all that does is it pulls whatever character I entered into the standard input window, and it takes it and it stores it in my variable, and in this case it prints it back out to me. Now let's contrast that with scanf. So here I have a char string. Now I've declared an actual string, which we'll talk about in a second, and I have char x, which is a character like we've seen before. You'll notice that this string looks awfully familiar to how we declare arrays, and that's on purpose. So we're going to contrast here what we can do when we enter a character or when we enter a string. And remember, a string is just an array of characters. So let's run this. It should spit back out to me what I put into it. Okay, so enter a character. Let's enter J and enter a string. Let's just enter something simple like hello world and see what happens. Now in theory, this should just print these back out to me. So it printed back out my character just fine, but what happens when I tried to enter that string that has 2 words? It turns out scanf doesn't know what to do when it encounters a white space. So I can type as much as I want, but as soon as it gets to a space in whatever I entered, which was up here, it no longer considers that part of the string. So scanf is not an ideal way to scan in strings, but it is a perfectly fine way to scan in characters. Let's look at this output here. So here we have putChar, and we're going to contrast that with printf. So let me build this. Okay, so right now we've declared a string, and I'm not even entering it in it, I'm just declaring it right here. My string says this is a test. How I'm going to spit that string out is use a for loop, right? I'm just going to put one character at a time for whatever number in my array here I'm at, and it will print this out one character at a time up to a max of 20 because that's the maximum array size I have. So let's look at how this works. All right, so it printed it back out to me. Your string, this is a test, done. Perfect. But let's see, because remember I told you that putChar actually works by converting your character to the ASCII table number. So here, I've just declared a variable I, I've set it equal to 49. Now, if you know your ASCII table, you'll know what 49 is. If you don't, you can pause the video and look it up and see if we're right here. And then I've said putChar I. So I'm going to put my character, right, putChar to the standard output, and it's going to be this number character. And then I'm going to print a new line. So let's see what happens if we run this. And it should still run our first string up here as well. Now, did it print 49? No, remember this converts to an int. So 49 on the ASCII table is actually 1. And then it printed our new line, and it prints done at the very end. So just be careful as we get into putChar and getChar and using those functions, because they do use the ASCII table, you will have to convert. Lastly, let's just do one last example here. If I declare a float A that's equal to 3.7 and I try and use putChar and put that onto the standard output window, what do you think will happen? Take a second and think through this really quick before I run this. You can pause it if you need to. What do I think will happen if I try and put char afloat? It gives me garbage, right? It doesn't know what to do. Because remember, put char converts things to integers using the ASCII table. As soon as it gets to a float, it doesn't know what to do. So I get junk. Okay, lastly, let's look at printf. So printf should be able to print strings perfectly. You'll see our placeholder here, %s. Now, remember with scanf, we struggled with this because it didn't know how to interpret the white space in between words. Will we have a similar problem with printf? No. Printf works just fine, and it will print strings just normally to the standard output window. So if you want to print an individual character, or if you want to print an entire string, you can always use printf. Okay, let's jump back into the PowerPoint. Just want to touch quickly on a couple other character functions that you can use. These are for individual characters at one time. So you could process a string by putting these inside a for loop, but this is processing one single character at a time. So we have int is alpha, int is space, and int is punct. And all this is doing is seeing if the character you entered or the character it's checking is a letter, is a space, or is punctuation. There are several other of these. You can look them up in the library. These have their own library, which is ctype.h. You can also do character conversion. Now you could probably write these functions yourself pretty easily, but they are built into this library if you want to use them. And this is int to lower. So you have an uppercase character and it converts it to lowercase. And int to upper, this takes a character and converts it to uppercase. Okay, so we've talked a little bit about strings in the past. We also touched on them in 106, if you remember. But the point is, strings are just character arrays. All they are arrays that instead of being filled with numbers, are filled with characters. The special thing about strings that makes them different from normal arrays is that they have to have an extra space on the end. They have to have this special termination character. This special termination character is called a null character. And because of this, you always have to remember with strings, this part right here. You have to declare it one bigger or one more than the total number of characters you want to hold. This is really important, and I'll show you an example that illustrates this in just a second. C also has special string handling functions. To use them, you have to include the string.h library. The individual character functions, the C type, is not the same library. So to use those, you use C type, but to use string functions, you have to use string.h. They're different. Okay, so like we said, the string ends with a null character. This right here is actually the null character. It's \0 inside those single quotes. Now, why did I include the single quotes here? To show that it in and of itself is one character. This thing is one character, it's the null character. So let's look at an example. Let's say we have a string, we call it S1, and it contains the characters EGR107. Maybe it looks something like this, right? These are our locations in memory. These are each one unit of memory. In this case, they'll each be 1 byte because to hold a char type, you only need 1 byte, 8 bits. We can declare our string, right? It starts right here, and we store EGR107. It is not technically a string until we also have this null character on the end. This tells our compiler, hey, this string ends right here. If I didn't have this, it would continue to think that any other junk I had in these other memory units would still be part of the string, and that can be a huge issue. However, this is included in the size of the string, so I always have to make sure I declare my array, my string, to be 1 element bigger than what I actually need. Okay, let's talk about the few different ways you can initialize a string. Okay, so if you remember from the array discussion in EGR 106, and if you haven't looked at that in a while, or you haven't used arrays in a while, I'd highly recommend you go back and either look at your Zybooks or look at the arrays PowerPoint from 106, because it'll help jog your memory a little bit. But if you remember, when you declare an array at the very beginning, if you declare it from the very beginning, you put the numbers inside curly brackets. That's slightly different for a string. For strings, if we want to declare it from the very beginning, we put it in double quotes. Specifying the array size is optional, just like for numerical arrays. So if I have this, I've declared a string, right? Technically, I don't have to declare the size. This will give me a bunch of space in memory, however many it can hold at one time. And then I say, this is what I want to set my string to. It will automatically store the null character for me if I do it this way. So I'm saying my string of indefinite length here is going to be HELLO null character. And it does this process for me. This is called static string initialization. How many elements are actually inside the array or the string str1? Is it 5 or is it 6? Well, we have to account for that null character. So this actually has 6 things inside of it. So you have HELLO and then the null. But when I number these, remember, if I were to number each of these individual elements, this would be 0, 1, 2, 3, 4, and 5. So we have 6 elements total, but the element numbers are 0 through 5. Let's look at this example here. char, string 1. We haven't declared how big it is, but we've set it equal to hello. Remember, this adds the null for us. And then we have a for loop. This for loop has a bracket around this line, so we're going to print one character, right, %c, of string 1 going through our for loop. So starting at 0 and going to 5. And then we're also going to print out the string just as is. Remember, printf can take many, many different data types. So what actually prints here? Take a second, pause the video and guess. What actually is going to print here is hello, hello. As soon as it reaches the null character, it knows not to print that. It knows that the string is over. All right, so why do we have to use the null? When we use %s, %s is the placeholder that we use for strings when we're talking about printf and other functions. When we do this, remember, we're still talking about arrays. So when I have str1 as the name of my array, remember all the way back to 106, what does that actually mean? What is the name of the array? The name of the array is a pointer to where it starts in memory. Remember, the pointer is actually, it holds the address. It points to the start of the array in memory. That means, by definition, every single time we declare a string, its name is always a pointer to a char. It points to the beginning of my character array. So as soon as I use printf, as soon as I take my printf and I use %s to print this string, and as soon as it gets to the null, it's going to go from that starting point in memory and keep going. As soon as it gets to the null, it knows it's reached the end and it stops displaying characters. It sees that null and it says, okay, it's done. No need to display anything else. So we just talked about static initialization. We can also initialize things that maybe aren't necessarily strings or that need just individual data points entered. So let's talk about how to introduce strings when we do it this way. So I've declared my string. I have to declare it in memory. In this case, I've declared it 20 big. I can declare my 0th element equal to e. Now, why am I using single quotes here instead of double quotes? Single quotes mean it's a character. So if I'm storing these individually, character by character, I have to include them in my definition here as a character. These have to be in single quotes, not double quotes. Now, if I start doing this one after the other, can you tell what's missing here? Right now, technically, if I tried to print this, right? If I tried to print this out using %s, what would happen? It doesn't know that I only want to print these things. It thinks I want to print this entire string, right? Because it knows, hey, start from here and go to the null. That's a string, right? Start from my pointer, where it points to it in memory, go through until you reach a null. Well, do I actually have a null in here? No. So this will actually print out any other stuff that's in memory behind this. It will keep printing for 20 different characters, because that's how big the array is. In order to actually be considered a string, it has to have a null character at the end. So this will print EGR 107, but then it will print a bunch of junk after that. Okay, so if I wanted to declare my string with each of these individually, how would I overcome this? What I have to do is add the null manually. So I have to actually add this character here at the very end of my string to tell my compiler, to tell my computer that, hey, when I want to print this string, I only want to go to here. If I don't do this, in this particular case, I'll print out all 80 characters of that array because it won't know when to stop. So remember, if you declare it individually one by one, you have to add the null manually. Okay, so let's talk about scanf. We saw that scanf doesn't really work that well when scanning in strings. And why was that? It's because when we put a space in between our strings, if our string is more than one word, scanf doesn't know how to handle that white space. It doesn't know how to handle that string. So it only reads up until that first word that you have. And this can be a problem. To get around this, if you really want to use scanf, you can read two strings back to back if you're expecting two different words, for example. So in this particular case, if I use scanf and I am expecting the user to enter hello world, or maybe their first name and their last name, or something like that, I can scan in two separate strings separated by a space, or whatever I'm expecting them to separate their words by. This would actually work, and I'd have two different strings, one for hello with a null, and one for world with a null. And why does it add the null for me? Because I use scanf and because I use that %s placeholder. If I wanted to read this in all at one time, would I be able to use scanf? Like down here, would I be able to read two separate words in using this function? No, it would only read hello, and then it would think that the string was done because it saw a white space. So it's better not to use scanf. Instead, when we're scanning in a whole line of text from our standard input window, we want to use the function getS. This right here is the definition for getS. When you actually type it, you don't need to put these pointers here. It's just telling you, hey, this goes to a pointer and this is a pointer. They're both pointers to chars. This will read whatever you type in on that entire line, including spaces, including punctuation, anything you want. The only thing it ignores is the enter you press at the end. So it ignores that last new line. So let's say we're using getS. We type in hello world. This will result in my string being hello with a space as a character, and then world with an exclamation point, and then it adds my null for me. getS adds my null for me. Now when I go to print this out, if I were to use printf, it would know to stop right here as soon as it reaches the null, and it wouldn't need to print out any of the other stuff stored in these memory locations. Now you'll see here, it reads at most max size -1. That's because we'll always encounter the null character at the end. How about other string handling functions for output? Now we've already talked about printf. We can technically use printf for strings. Printf can handle all sorts of data types. But we can also use the companion to get s, which is the function putS. So putS, constant char, this is still a pointer to a string. You'll declare it just like anything else. When we have our string, maybe it's 101 big and we've entered hello world, right? Upon declaration, when we do this, do I have to manually enter the null or is it added for me? It's added for me when we define it like this. And then I do putS, whatever my string is. This will print out whatever's stored at str, which just happens to be hello world exclamation point. You can also do this for the file version. You can print to a file using strings with fputS. You have to do this with the string itself, the address at the start of the string, and the file pointer. So let's look at an example. Okay, first I want to touch on this. This isn't specifically talked about in the slides, but I really want to make sure you understand why this doesn't work. If I were to try to build and run this function, take a second here and think about if I'm going to get an error trying to run this or not. And I'll build it for you. And I do get an error. My error is in line 7 and it says assignment to expression with array type, error. Now, why am I getting an error trying to declare it like this? What actually is this? Do you remember? Remember when I declare an array, even if it's a char type array, even if it's a string, the name of the array is the pointer. It points to the address in memory where this array is stored. So right now I'm trying to set the pointer equal to this text. Is that going to work very well? No, it's not. In order to do this, I have to do it when I initialize it. So if I initialize it and I set it equal, this will work and it will add that null for me. And you can see as soon as I build it, I get rid of my error. And if I run it, it will print this out for me just fine. So if you're having trouble, double check that you've actually declared your string when you declared it and initialized it. Okay, let's get into our getS example. So here, normally we'd printf, enter a string, and then we'd use scanf in order to take in a character or a number. That's what we've learned so far. Instead, I'm going to ask you to use getS. It will take whatever you enter on the standard input window, and it will store it starting at string using as many memory locations of the 50 as it needs. So if I enter a string that's 10 characters long, it will use the first 10 of those and assign the null character for me. And then when it prints back out, it will print out only those 10 that I wanted. All right, and you can see I enter this as a test and it spits back at me. This is a test. It doesn't print the rest of those 50 because it added that null character as soon as I entered it. It knows that's all I want. And let's look at a super simple putS example. I've declared my string as hello world, and then it's going to putS from the start of the string until it reaches a null character. Because I did this on my declaration, my null will be right here, and it will know exactly when to stop. Again, prints out hello world perfectly, no big deal. So when you're using strings, I'm going to encourage you to use getS and putS. This will make your life a lot easier than having to use scanf. Okay, so quick review here. You can actually use scanf and printf with strings. But scanf is limited because it doesn't understand how to handle white spaces. If you want to enter things a line at a time, scan things in a line at a time and put things to your output a line at a time, you can use getS and putS. These automatically use the standard input window or the serial monitor, which is great. You can also do similar things with files. So for example, if I wanted to read in a line at a time from a file, I could use fgetS. And if I wanted to print something into a file, I could use fputS. Now, same thing, whenever we're using files, we always have to include that file pointer But this way, it will actually read in every character from that file into one single string. It also keeps the new line at the end. This does not put a new line at the end for you in fputs, so just keep that in mind. You'll have to add that manually if you don't want all your data crunched together. All right, let's look at an example of fgets and fputs. Okay, so here I've declared a string. I've also declared a macro variable. My macro is going to be max 100. That just means that I have a maximum of 100 characters inside my string. It's called string1. And I've defined it right here. I could have used gets to enter it and then puts to print it back out. Remember, that's just from the standard input window. But for ease of this example, I'm just defining it right here. It's called test string. I'm going to print it back out to my standard output window just to make sure it printed out correctly. Remember here, we just use the name of the string, whatever its name is, because we need the pointer. Now let's say I want to then get a new string from an input file, store it in string1, and then print that string into an output file using text documents. So I have to use my file pointers. Do you remember the 4 steps for using files in C? If you don't, we're going to run back through it quickly, but please make sure you remember to review this from 106. So the first step is to declare your file pointers. They usually start with FP, although they don't have to, and this file construct has to be all capitals. So I've declared file pointer input and file pointer output. You need a file pointer for every file you're opening. I have to then open my files. Step 2 is opening the files. So I set my file pointer equal to fopen input.txt, and I'm opening it in a certain mode. If you remember the mode options, there are W and A. R for read, W for write, A for append. I have to do the same thing for my output file. I still have to open it. Sometimes you may want to check and see if this file exists. I know that it exists because I just put it in my documents, so I'm not going to bother checking it. The next thing I have to do is actually modify it, so read something in or write something to the files. So I'm going to use fgets, this new string function that I just learned, to pull the string from my input file, right? I'm going to store it in string1. It has to know how many characters I have in string1 max, because it doesn't want to read over that number. So I've defined string1 as 100 using that macro, so I'm going to use that macro here too. This will probably always be the same size as your string. And I have to tell it where to pull from. In this case, this is my file pointer for my input. I'm then going to print that string to the standard output window just to make sure I got it right. And then I'm going to write that string using fputs to my output file. My output file, remember, is called output.txt. Now, do I have to check and see if that exists? No. If you remember, it will actually be created for you if you don't have a file called that already in your file explorer. The very last step that a lot of people forget is closing the files. Don't forget to close the files. You close the files with the file pointer names. All right, so I'm just going to build that and make sure everything looks good. So if this runs correctly, I should print test string, and then I should open my files, pull the string I have in input, put it on the standard output window, put it into my output file, and then close my files. So let's see what I have in input. I have you did it, you read in the file, that's good. All right, and because I ran this already, I already have this in here, so let's delete that. I have it saved now, so my output file is empty. And let's run this and see what happens. So at first it printed test string because that's what I had stored in my string. Technically I didn't need to do that, I just wanted to show you that it works. Then I overwrote my string with you did it, you read in the file, reading in from my input file, so I know that that worked. And to see if it actually fputs to my output file, I'll need to open that. And you can see that it did. It did put that string into my output file. Yay, we did it! Okay, so this has been a summary of part 1, which is Introduction to Chars and strings using basic string assignment. So if you get confused about strings, just remember that strings are just arrays of characters. You have to define your array one greater than you would normally with numerical arrays just because of that null character. That's how your printf or your fputs or your fgetS knows where the string ends. If you declare this statically in C, it will add that null character for you. You have to remember to add it yourself if you declare your array one element at a time. We can process strings one character at a time using getChar and putChar, as well as getFC and putFC. We can process strings entirely at one time, and this is what I recommend doing with getS and putS, or fgetS and fputs. And you can process strings using the %s with scanf and printf, but remember with scanf, you can have some issues with white space. All right, so that does it for part 1 in our strings lecture. Thanks for tuning in with me. In part 2, we're going to talk specifically about more detailed string functions that are specifically in the string library. So less to do with assignment and more to do with string manipulation. Thanks for joining me for part 1. You should be able to find part 2 link in the description below, and it's probably linked on your Blackboard site as well. Thanks for joining me, and I hope to see you in part 2.